Hi, everybody. So this question is asking, what is the maximum tension possible in a 1 millimeter diameter nylon tennis racket string? So let's do like a little string here. And then we have a diameter of, we'll put D as 1 millimeter. And B, if you want a tighter strings, what do you do to prevent breakage? Okay. So here, let's just find, we have diameter, and you know the drill is when we find the diameter, we always have to find the radius, okay? It's just one of those things that, it's just good, even if you don't need it, it's sometimes one of those things, it's just good to find it. And it's still going to be one, and we're going to convert this really quick to meters, because we like meters in this household. And so we have 1083 m squared divided by 1 millimeter. Okay, and we're just gonna boop. Okay, and 0.0005 meters. Okay, and so we got to find the tensile strength of the nylon. Okay, which is with F before we begin. And then when we do this, we have to find the maximum tension of the nylon tennis racket. And we do this again with F over A, force. So before we do this, we are actually going to be using this equation here. F equals A, area. A is for area. And this is going to equal to 500 times 10⁶ in m squared. And that's what we're going to use just to solve for A, okay? And that's what we'll be doing. We're trying to find F for this equation. Okay, so let's start solving. And this is the tensile strength of nylon. By the way, the tensile strength of nylon is that. And we're just going to go backwards. And so we're going to put A over there because we don't need it here. Times 10⁶. And I'm just going to bracket it times area. Okay, and what I'm going to do is, if you write area, we're just going to put the area of this string, if you can guess, it's going to be pi r squared. Okay, now we are going to have 500 times 10⁶ in m squared times pi times 0.005 meters squared. If you notice that your meters are going to cancel out, and we get 393 newtons. And that is your answer for A. And now for B, your B is just going to be a focus question. So B is, if you want a tighter string, what do you do to prevent the breakage? Okay. And so thicker strings can be used to prevent breakage. So we can use thicker strings to prevent breakage. I can spell breakage. Does not have a C in there. See? I'm just going to not know how to spell breakage. It's okay. It's okay. This is not an English class. It's fine. And because when we tighten the strings have to absorb. So, and that's because when you tighten, strings, they absorb the force or the tension, otherwise known as tension. If you use thinner strings, they have less area, so they so thinner have less area and will break as the ball hit the string. Okay, so they're absorbing the longer